So this is for the sort of problem in low voltage AC circuit, resistive AC circuit. So at the end of this session, students should be able to apply their own laws in resistive AC circuit, state the phase relationship between voltage and current in a resistive AC circuit, draw the phasor diagram for a resistive AC circuit, calculate the power consumed by a resistive AC circuit. So that this is for the impedance. Impedance equation is Z equal to V divided by I. This is own law for the AC circuit. Impedance Z is a 3 component. That will be a resistance. This is for the horizontal line resistance. Inductance is a H particle line, and this is the HA is an inductive reactance, H is a capacitive reactance, Z is an impedance. This angle theta is the angle between voltage and current. So this is the component of the resistive AC circuit. So that this is called the impedance of triangle. Then we're going to talking about the power triangle. So this is the power triangle, the angle between voltage and current. This power is apparent power S. This is voltage multiplied current. So Vi cos theta is a real power. P equal to Vi cos theta real power. The cos theta is called the power factor of the circuit because it related to the real power to apparent power. So this one is apparent power. And here is the vertical is a Q. Q is a Vi sin theta or reactive power Q. So in this case, this is a circuit here. This is the VT current flowing, ID current flowing. In a purely resistive circuit, the current is in phase with the voltage. So resistive current is in phase with the voltage. In this case, the vector diagram, current and voltage diagram, you can draw like this. So the for the power triangles are S equal to Vi, P equal to Vi cos theta, Q Vi sin theta. P equal to Vi, in this case, Q equal to 0 for the pure resistive circuit. So in this case, the voltage and currents are in phase. Voltage is purple, you can see current here, they are in phase. This is for the pure resistance circuit. Power will be there, the black one is a power is ever positive. So resistance is a property of circuit. This that opposite current flow. In any circuit, Z equal to V divided by I. So that in purely resistance circuit, Z is equal to the R. So that in the AC circuit, the voltage continually changing, but the resistance is constant. So in this case, resistance and the voltage are the purely. So in this case, a phase angle is a 0 because Z and I are the same. Then we're doing about the example calculation. In this case, you have to know the formula V equal to Z equal to V by I, S equal to V into I, P equal to Vi cos theta, Q equal to Vi sin theta, Z equal to the R. Example 1, that the element of the toaster has a resistance of 60 ohm, determine the circuit current if the toaster is connected to the 240 volt 50 Hz supply. What do we know? In this case, R equal to 60 ohm and V equal to 240 volt. What do we want to know? I equal to V divided by Z. So the 240 by 60, you got a 4 ampere. A purely resistant lamp is connected to the 24 volt 50 Hz supply. If the lamp draws at 1.25 ampere, determine the circuit resistance, circuit impedance, power consumption. So what do we know? In this case, our voltage 24 volt, current 1.25 ampere. What do we want to know? We want to know that Z equal to R, Z equal to V by I, and then power equal to Vi cos theta. So in this case, Z value we find out 24 by 1.25, Z got 90.2 ohm, and power equal to 24 by 1.25 multiplied by 1, you got the 31. This is the we got. The next problem is 2K2 ohms resistor is connected to the sideway generator. If the frequency of the signal is set to be the 2 kHz and the circuit draw the 4 microampere, determine the output voltage of the generator. What do we know? So we know that Z equal to I equal to 2K2 also, and also the frequency 2 kHz, current 4 microampere. What do we want to know? We have to know that V equal to IZ, we equal to 2200 multiplied by 4 microampere, so the 8.8 millivolt we got. The circuit has a resistance of the 20 ohm and then draw the current of the 16 ampere. Determine the applied voltage, circuit impedance, and the power drawn by the circuit. What do we know? We know that resistance 20 ohm, current is 16 ampere. What do we want to know? In this case, voltage equal to Z multiply ZI. So in this case, V equal to R, P equal to VI. So then in this case, Z equal to I equal to 20 ohm, P equal to, so V voltage equal to ZI, so 20 multiplied 16, you got the 220 volt. Power equal to V into I, so 320 multiplied 16, you got the 5.12 kilowatt. Then this is for the answer we finish. The next one will be the resistance capacitive AC circuit. So UENE G102A saw the program in the low voltage AC circuit. We know about the capacitive AC circuit. At the end of this lesson, students should be able to list the effects and the application of capacitor in AC circuit, define the terms of capacitive reactance, draw the impedance current and voltage phasor in the ID capacitive circuit, calculate the impedance current and voltage in an ID capacitive circuit given certain characteristics, and calculate the impedance power consumed by the capacitive AC circuit. So this is for the capacitive AC circuit. Capacitor C connected voltage VT. Capacitor is a property of circuit that opposes the change in voltage. In a pure capacitive AC circuit, the current leads the voltage by 90 degrees. So this is the current leads the voltage by 90 degrees. And in this case, the power triangle, V equal to S equal to VI, T equal to theta, and the P equal to VI cos theta, Q equal to VI sin theta. In pure capacitive circuit, the lead the voltage theta is 90 degrees. So this is the voltage here, the current here. Voltage lead the current by current lead the voltage by 90 degrees. So this is the power. Well, this is Q. The reactive power Q equal to VR. Real power is 0. And capacity is a property of circuit that opposes the change in voltage. So the any circuit Z equal to V by I. Z is equivalent to the AC. So the AC equal to 1 by 2 by SC. In this case, S is the frequency, C is the capacitance value. So this is AC value, this is Z value, this is R value. And example calculations are CIVIL. So this equation. So in this case, Z equal to V by I, S equal to VI, P equal to VI cos theta, Q equal to VI sin theta. Z equal to approximate to the AC. So AC equal to 1 by 2 by SC, S equal to 2 by L. Determine the impedance of pure capacitive circuit which draw the 4x7 ampere from the 240 volt 50 Hz supply. What do we know? I equal to 4x7 ampere, we equal to 240 volt. What do we want to know? Z, we need to find out. In this case, the Z equal to AC. So AC equal to V by I. AC equal to 240 by 4 by 7. You got the 51 ohm. Determine the reactance and the circuit currents are drawn by an 8 microfarad capacitor connected to a 240 volt 50 Hz supply. Draw the phasor diagram for the component. What do we know? So C equal to 8 microfarad, V equal to 40 volt, F equal to 50 Hz. What do we want to know? AC equal to 1 by 2 by SC, I equal to V by Z. So CIVIL, so we calculate. So in this case, the phasor diagram is drawn in a different scale. So the AC equal to 1 by 2 by SC, so 1 by 2 F, 2 by multiplied 50 into 8 microfarad, I equal to V by Z. So AC value is 397, Y is 89 ohm, I equal to V by Z, 240 by 397, Y 89, we can calculate the current is 0.603 ampere. So current is 0.6 ampere. Single phase a synchronous motor draw the 40 ampere with the leading power factor of the 0.22. Draw is a 240 volt. So 50 Hz supply determine the period and true power. So what do we know? Currents are 40 ampere and also power factor angle, power factor is 0.22 leading and voltage is 240 volt, frequency 50 Hz. What do we want to know? In this case, appearance are power target, appearance power, this is real power, reactive power, this is angle. S equal to V into I. 240 multiplied by 40, you got then 9.6 kVA. P equal to VI cos theta. Cos theta is a value is given, so the power equal to 9.6 multiplied by 0.22, you got the 2.1 kilowatt. Calculate the phase angle for the circuit which has a power factor of the 0.1 leading and a 0.33 leading. So in this case, what do we know? Power factor angle values are given the 0.1 leading and 0.33 leading. Circuits are capacitive. apparent power, the reactive power, and real power. So what do we want to know? Theta A is you have to find the cos value, cos inverse 0.1, so you got the 84/26 degree. Theta B is a cos inverse 0.33, you got the 70/73 degree. And this is for the phase angle. Phase angle for circuit, power factor 0.1 leading and 0.3 leading. So there will be the power factor 0.1 and 0.3 leading, we can calculate by this way. Capacitance of the calculate the capacitance of capacitor if the capacity reactant is 100 ohm at the frequency 50 hertz. So then what do we know? H equal to 100 ohm, F is 50 hertz. What do we want to know? Capacitance we have to find. So H equal to 1 by 2 by SC. So the C equal to 1 by 2 by FXC. So 1 by 2 by 100 pi into 100, you got the 31/8 microfarad. Determine the current taken by the 100 microfarad capacitor, which is connected to a 230 volt 50 hertz supply. What do we know is that capacitance is 100 microfarad, voltage is 230 volt, frequency 50 hertz. What do we want to know? We have to find the current. So H equal to 1 by 2 by SC, 1 by 100 pi into 100 mu, you got the 31/8 ohm. V I equal to V by itself, 230 by 31/8, 7/23 ampere. Then you have to do the practical exercise. Then we also talk about another inductive AC circuit. Inductive AC circuit, we talk about. So the sort of problem in low voltage AC circuit, inductive AC circuit. So at the end of this lesson, students should be able to list the effects and application of inductance in AC circuit, define the time inductors are reactant, draw the impedance circuit, impedance current and voltage phasor in the IDs are inductive circuit, calculate the impedance current and voltage in the ID inductive circuit given certain characteristic, calculate the power consumed by the inductive AC circuit. So this is for the inductors are connection, is the inductor current flowing. Inductor is the properties of the circuit that oppose the change in current. The pure inductive circuit current less the voltage by 90 degree. So this is current less the voltage by 90 degree. We are inductive circuit. And it's also the power triangle. P equal to VI cos theta, S the VI, Q is the VI sine theta. Pure inductive circuit, let the Q is a minus 90 degree, cos minus 90 is 0, sine minus 90 is minus 1. So this is voltage and the current we got. And here is a phasor diagram. This is the Q. P is 0, Q equal to minus VI. Practical inductor has a same resistance and therefore the use as some real power I square R. Inductors are used in the AC circuit because they use a very little real power. Inductance is a property of a circuit that opposes a change in current. So any circuit Z equal to V by I. So that in this case Z is proportional to the HL, H as an inductive reactant. In the AC circuit of the voltage continually changing and the inductive reactant is a frequency independent. So H equal to 2 by FL. Phase angle is a theta 90 degree. This is H value. Then we have to calculate Z equal to V by I, S equal to VI, P equal to VI cos theta, Q equal to VI sin theta. So Z is approximately to the HL, magnitude of HL is 2 by FL. So determine the impedance of the inductor if it draws the 1 by 8 ampere from the 230 volt 50 hertz supply. So what do we know is that I is to 1 by 8 ampere, V 240 volt. What do we want to know? Z, we have to determine Z equal to HS approximately equal to the voltage by I current. So in this case, Z equal to HS to V by I, 240 by 1 by 8, you got that 133.30. The next problem, determine the impedance and inductance of the coil with the magnetic J value of the resistance, which draw the 0.2 ampere when connected to a 240 volt 50 hertz supply. Draw the phasor diagram for this component. What do we know? We know the current I is a 0.2 ampere, voltage 240 volt, frequency 50 hertz. What do we want to know? Impedance Z. In this case, Z equal to HL equal to V by I. HL equal to 240 by 0.2, you got a 1200 ohm. HL equal to 2 by FL, then you have to find out the L equal to HL by 2 by F. 1200 divided by 2 by 50, you got the 3 by 8 200. Then you have the diagram, the body here, this is current. So this is a phasor drawing diagram. Draw the VI power phasor diagram with the value for the 0.2 Henry coil with a negligible resistance when it is connected to the 240 volt 50 hertz supply. What do we know? A is equal to 0.2 Henry, B equal to 240 volt, F is equal to 50 hertz. What do we want to know? CI, VIL. So in this case, this will be the phasor are the draw in different scale. Voltage 240 volt. So I equal to V by Z. So in this case, H equal to 2 by into 50 into 0.2, you got the 62.80. I equal to 240 by 62.8, so 3.82 ampere we got. The next problem is whether draw the 40 ampere with the lagging power factor of 0.22 from the 240 volt 50 hertz supply. Determine the apparent and the true power for the weather. So what do we know is I to 40 ampere. In this case, angle is 0.22 leading voltage 240 volt, frequency 50 hertz. What do we want to know? So this is real power triangle. This is theta apparent power. This is reactive power. So S equal to VI you got. S equal to 240 into 40 and 9.6 kVA. P equal to VI cos theta. So angle is at cos theta. P equal to 9.6 kilo ohm multiplied by 0.22, you got a 2.1 kilowatt. Calculate the phase angle for the circuit. Power factor is a 0.76 lagging and 0.96 lagging. What do we know? So the angle is a 0.76 lagging and 0.96 lagging. The circuits are inducted. Real power, reactive power, apparent power here. What do we want to know is theta is cos about 0.76, you got the minus 40.5 degree. Theta is the cos about 0.96, you got the minus 65 degree. The next problem is ID inductors draw the 10 ampere from the 240 volt 50 hertz supply. How much current would it draw from the 120 volt 100 hertz supply? What do we know is I1 is 10 ampere, V1 240 volt, F1 is 50 hertz. What do we want to know? I2 is to determine V2 120 volt, F2 100 hertz. So that in this case, I equal to V by Z, Z equal to H equal to 2 by Fn. HL1 is V by I 240 by 10, so you got 24 ohm. So L equal to HL1 by 2 by S 24 by 2 by into 50, you got a 76.4 millihenry. HL2 is 2 by FF, so 2 by into 100, you got a 76.4 millihenry. Then you got a 48 ohm. Then frequency F is a 2F1, so the HL2 is 2HL1, so you got a 248 ohm. Then here you got the I2 is 120 so I2 2.5 ampere. Okay, this is for the advanced diploma electrical. So then we also do the advanced diploma electrical.